Let's take a look at the tangent graph. The first thing we can notice about the tangent graph is that it's not continuous, meaning that there are breaks from time to time. We notice the first of this break at negative 90, another one at 90 degrees, and another one at 270 degrees. These breaks are called asymptotes. If you remember, asymptotes are lines that the curve will go very close to but never touch. If we look at this asymptote, we can notice that these asymptotes happen regularly. So if we look at the difference, they happen exactly every 180 degrees. So 90 degrees plus 180, that's 270. If we go on the other side, 90 degree minus 180 degrees, that's negative 90. And at negative 270, we have another asymptote. From this, we can deduce that the period of the tangent graph is 180 degrees. A few other points that are important on the tangent graph is the point that will go through the axis of the curve. So in that case, the axis of the curve is y equals 0. The points where tangent go through the axis of the curve are at x equals 0, x equals 180, x equals 360. The tangent has a period of 180 degrees, so we can also go on the negative, and at negative 180 we are at the axis of the curve. The other interesting point is the amplitude. Here we have the graph of tangent theta, so the amplitude is 1. And as the amplitude is 1, we can see that the graph goes through the point 1 at 45 degrees, 225 degrees, negative 135 degrees. So these lines replace the maximum line of the cosine and the sine function. One thing you can notice is on the cosine and sine function we had a maximum. Here, because of the asymptote, we don't have a maximum. So the tangent lines goes up to infinity and goes down to minus infinity. So there's no maximum, no minimum. Same thing, as we have an amplitude of 1, we can find on the negative side, the points that are interesting are for y equals negative 1. So we have one at negative 225 degrees, and then every 180 degrees, so negative 45, positive 135, and positive 315. These points are the points that you need to create your tangent function. So if we look at it on the first period, the interesting points are going to be 0, 45 degrees, 90 degrees for the asymptote, 135 degrees for the negative amplitude, 180 degrees at the axis of the curve, and we have one full period. One thing you can notice compared to cosine and sine is that when we graph our tangent graph, instead of going every 90 degrees, we go every 45 degrees instead. When we ask you to graph a tangent, the tangent will be of the form A tangent theta plus B. Same as before, y equals b is the axis of the curve. The amplitude is what we multiply by tangent. This helps you to graph your curve, as the curve will go through the point b plus a and b minus a at certain degrees. When you have to graph your tangent, the first thing you need to do is to place your asymptote. The asymptote will always be at 90 degrees and every 180 degrees after that. After that, we know that for 0 degrees we're at the axis of the curve. For 45 degrees we're at b plus a, so axis of the curve plus the amplitude. 90 degrees we have the asymptote. 135 degrees we're at b minus a, so axis of the curve minus the amplitude, then axis of the curve. And if you continue, you can just repeat the period over and over again. Remember that we go close to the asymptote, but we never touch it. So your graph shouldn't touch the asymptote even though you go very close to it. Let's look at an example. Sketch a graph of y equals 3 tangent of x for x between 0 and 360 degrees and state the corresponding range. Okay, first thing we do is y equal 3 tangent of x. It means that the axis of the curve is y equals 0 and the amplitude A is 3. We don't forget to place our asymptotes. First asymptote is at 90 degrees. Second asymptote is at 270 degrees. Now we can start repeating the patterns of tangent. At 0 degrees, we're at the axis of the curve. 45 degrees, we're at b plus a. 90 degrees, we have the asymptote. 135 degrees, b minus a. 180 axis of the curve, 225, b plus a. And we repeat over and over again. And then, now that we have all the points, we can graph. Our tangent is now complete. Next thing, we ask you to state the corresponding range on that domain. Okay, we see we start at 0 and then we go up. Because we have an asymptote, it means that we never stop and we go all the way to plus infinity. When we start again, we start down here, so we start at negative infinity and we go back up to positive infinity. So in the end, if we look at the range, we can say that the range goes from negative infinity to positive infinity. Instead of writing it like this, we usually just say that the image of this function, so y, is a real number. Let's look at a second example. We have 2 tangent theta plus 1 and we want to graph it between negative 90 degrees and 270 degrees. So first thing, 2 tangent theta plus 1 means the axis of the curve is y equal 1. Our amplitude is 2, so we're going to get one line at 1 plus 2 and another line at 1 minus 2. So to help us, we get one line at 3 and one line at negative 1. The first asymptote is at x equal 90 degrees. Theta equal 90 degrees. If we go in the negative, we have 1 at theta equal negative 90 degrees, which is in the domain. And we have 1 at theta equal 270 degrees. Okay, now we can repeat the pattern of the tangent. So at 0 degrees, we're on the axis of the curve, and at 45 degrees, b plus a. In that case, we need to go to the negative side also. At negative 45, we're at b minus a, so on the point y equal negative 1. We get our first period here between negative 90 and 90. We simply need to repeat it again between 90 and 270. So we have 135, 180, 225. We can now graph the curve. We start close to the asymptote without touching it. We curve around the axis of the curve, and then we go back close to the asymptote. We do the same thing on the second period. And we have our curve between negative 90 degrees and 270 degrees.